You're standing in front of a mirror. Look at your skin. Whether it's light or dark pink or deep brown, you probably think of it as the most natural thing in the world. It's yours. It always has been. But there's a fact most people never realize. Go back far enough in time, and every single human alive today meets in the same place. Africa. For almost 90% of our species' history, all of humanity lived in Africa. The blonde Scandinavian, the Korean engineer, the farmer in the Andes, every one of them has ancestors who stood under the same African sun. And there, under some of the harshest sunlight on the planet, the first modern humans almost certainly had dark skin. Now imagine you took a photograph of one of those ancestors 200,000 years ago and placed it next to the 8 billion people alive today. One thing would jump out immediately. They probably wouldn't be white, they probably wouldn't be East Asian, and they definitely wouldn't be a redhead arguing with the sun every summer. Which leads to a very simple question. If we all started with one skin color, in one place, where did the thousands of skin colors we have today come from? You're about to see that the answer isn't a straight line from dark to light. It's a loop. Light. Loop. Light, then dark, then light again. And the first part of that loop is something almost nobody tells you. Because the dark skin of the first humans wasn't actually the beginning. Go back one more step, further than 200,000 years. The distant ape-like ancestors of your species, the ones who lived before we existed, almost certainly had light skin under a thick coat of dark hair. You can see the exact same thing in chimpanzees today. Shave off the hair, and the skin underneath is pale. The hair was the sunscreen, not the skin. So what changed? Your ancestors took off that coat of hair. Around 1,000 to 100,000 years ago, the genus Homo began losing most of its body hair. The reason seems tied to hunting and traveling long distances under the heat of the African savanna. Less hair, better sweating, better cooling, the ability to keep moving without collapsing. It was a huge advantage, but it came with a brutal cost. A bare body is a body exposed directly to the strongest sunlight on Earth. And this is where dark skin enters. Anthropologists like Nina Jablonski, along with geneticists studying a gene called MC1R, found that the gene was strongly selected and locked into place right around the time humans lost their hair. In other words, dark skin was never your original state. It was the first emergency solution for a body that had just shed its own coat of shade. So why did dark skin win so decisively in Africa? The answer is a substance called melanin. Melanin is the pigment that gives skin its darker color. But its real job is to block sunlight. More precisely, it absorbs ultraviolet radiation, the invisible part of sunlight we shorten to UV, before that radiation can damage the cells underneath. This dark form of melanin is called eumelanin, and in equatorial Africa, where UV is among the strongest in the world, having plenty of eumelanin wasn't about looks. It was about survival. And the danger doesn't stop at sunburn. This is the part few people know. In their work published in the year 2000, Nina Jablonski and George Chaplin showed that UV also destroys a substance in the blood beneath your skin called folate. Folate is essential for a baby to develop normally. Without enough of it, a pregnancy risks neural tube defects, serious malformations of the brain and spine. So, under the African sun, skin that wasn't dark enough didn't just leave you burned. It quietly eroded your ability to have healthy children. Over thousands of generations, dark skin became the right answer for Africa. At this point, you might think you've figured out the rest. Strong sun means dark skin. Weak sun means light skin. People change color wherever they go. Neat, logical, and wrong. That formula is only half right. The other half is where everything starts to break open. It doesn't tell you why the first Europeans kept their dark skin for tens of thousands of years after they had already walked into the cold. It doesn't tell you why Europe and Asia both arrived at light skin, but through completely different genes. And it doesn't tell you why an ancient Briton 10,000 years ago had dark skin paired with a pair of blue eyes. Sunlight did not repaint humanity in some tidy way. The real story is far messier than that. And it starts getting strange the moment humans left Africa. Around 60,000 to 80,000 years ago, groups of humans began leaving the continent. Some passed through the Middle East, some moved into Europe, some pushed east into Asia, and further still, all the way to Siberia and Australia. They had no maps, no compass, no phone nagging them to make a U-turn every few seconds. They just kept walking, generation after generation, farther and farther from the equator. And as they moved north, the sunlight changed. The UV grew weaker. At first, that sounds like good news. Like, less UV means less danger, right? But nature rarely gives anything for free, because the very sunlight that can harm your skin is also the sunlight your body uses to make vitamin D. Your skin uses UV as a raw material to produce the vitamin D that your bones and immune system depend on. Without it, bones weaken, immunity drops, children struggle to grow. Do you see the trap now? In the north, where there was already little sun, dark skin that blocked UV so well became a problem. It blocked the little sunlight the body needed to make vitamin D. The same skin that had saved lives in Africa was now quietly causing shortages in Europe. So natural selection reversed. Slowly, over thousands of years, in low sun regions, lighter skin began to be favored because it let more sunlight in. But why did some populations turn light faster than others, even at the same latitude? Diet, migration routes, mixing with other groups. Here the science is still arguing, and I'll leave you to sit with it. Tell me your guess in the comments. Now, here's where the story overturns everything you thought you knew about Europeans. You probably picture an ancient European as pale-skinned, blonde, blue-eyed, standing in the snow. Forget that image. The pale skin we associate with Europe today appeared far more recently than you'd think. In 2018, scientists at the Natural History Museum in London and University College London sequenced the genome of Cheddar Man, the oldest nearly complete human skeleton ever found in Britain, dating back around 10,000 years. The results stunned a lot of people. Cheddar Man had dark skin, dark curly hair, and blue eyes. In ancient Britain, dark-skinned and blue-eyed. And roughly 10% of the ancestry of indigenous Britons today still traces back to his people. This wasn't a one-off. In 2014, in the journal Nature, a team led by Inigo Olalde published the genome of a hunter-gatherer known as Labrana 1, who lived in Spain around 7,000 years ago. Same picture. He carried the gene variants for dark skin, the kind still seen in Africa, but he had blue eyes. Two individuals, thousands of years and hundreds of miles apart, telling the same story. It's almost as if evolution accidentally hit a random button on a character creation screen and just left it there. Dark skin, blue eyes, done. Go outside. So where did Europe's pale skin come from, and when? Much of it is tied to a gene called SLC24A5. In 2005, a team led by Rebecca Lamison discovered this gene while studying a pale variety of zebrafish nicknamed golden. The astonishing part is that the variant that lightens European skin differs from the ancestral one by just a single letter in the genetic code. One nucleotide. That tiny change spread across nearly all of Europe, and it only became common fairly late as farming spread, as diets shifted, as populations mixed. Not because it was superior, just because in a world with little sun it worked better. And while Europe was walking its own path, Asia solved the exact same problem in a completely different way. Imagine two students taking the same test. Both get the right answer, but each uses a different method. That's exactly what happened between Europeans and East Asians. Both evolved lighter skin than their African ancestors. But when scientists looked at the genes, they found the two groups used different sets of them. In 2007, research by Heather Norton and colleagues gave this a name: convergent evolution, when two groups of organisms independently reach the same solution through separate genetic paths. Europeans leaned heavily on SLC24A5 and a few other genes. East Asians relied on genes like OCA2, variants Europeans barely carry. Same destination, two entirely separate roads. And that's the moment the familiar model in our heads falls apart. We like to sort humanity into three neat boxes: black, white, and Asian. Simple, easy to remember. Also completely wrong. Human skin color isn't three colors. It's a continuous spectrum stretching across hundreds, maybe thousands of shades. North Africans differ from West Africans. Middle Eastern populations differ from Europeans. South Asians differ from East Asians. Indigenous Australians walk their own path. Native Americans carry traits from groups that migrated through Asia before writing existed. Humanity didn't split into a few boxes. It spread into one continuous, messy gradient, exactly the way evolution does everything. And now the strangest part of all, if you go back far enough, every human alive today traces back to the same populations in Africa. Every single one. The darkest skinned person and the lightest. The blonde Scandinavian, the Nigerian athlete, the Korean engineer, the Andean farmer. Go back far enough and the family trees begin to merge, the branches folding back into the same trunk. Here's the number that makes it feel almost eerily real. Remember Cheddar Man's blue eyes? In 2008, a team led by Hans Eiberg at the University of Copenhagen found that nearly every blue-eyed person on Earth today traces back to a single common ancestor, someone who lived around 6,000 to 10,000 years ago. Before that person, it's likely no one on Earth had blue eyes. A single small mutation in a gene called HER2 turned down the brown pigment in the iris. And from that one human, blue eyes spread across the world. Every blue gaze you've ever seen is a copy of the same chance moment in history. Let that settle for a second. The differences we notice most in each other, skin color, eye color, are actually very recent. Our species spent far more time looking similar than looking different. The last few thousand generations are just a blink in the whole history of Homo sapiens. And beneath all those surface differences, humans are genetically alike to a degree that's hard to believe. Far more alike than most people imagine. Which brings us back to the mirror, where we started. The face looking back at you isn't a fixed state. It's a single frozen frame cut from a loop that has never stopped turning. Light. Under the hair of your ape ancestors. Dark when humans shed that hair and stepped out under the African sun. Then light again in the sunless lands of the north through different genes, different paths, different worlds. The same species. Just meeting different skies. The remarkable thing about human skin color isn't that we're different. It's that we're different in such predictable ways. A little more sun here, a little less sun there. Thousands of years pass, genes shift, and humanity quietly repaints itself in new shades. Not because it split into separate species, but because one family walked toward different horizons. So the next time you look in the mirror, remember this. What's looking back at you isn't a skin color. It's 1,000, 1,200,000 years of sunlight, thousands of miles of walking, and a loop of light, dark and light again, that has never once stopped. You're not looking at difference. You're looking at the same story, just told under a different sun.